Learning about addition.
No, we're learning about math, and we're going to learn. I was asking what you remember about when we started learning about addition. What did we talk about? What is math? I used a fancy word that starts with Q. Do you remember what it was?
No.
I said it's a quantification.
Quantification.
Yeah, what does quantification mean? Do you remember?
No.
It's a way of describing how much. Quantity means how much. Quantification is we're describing how much. And when we started about addition, we talked about how math is consistent, right? We said we have here sets of the same thing, right? We have 3 and 3. Let me turn it so you can see 3 and 3. It doesn't matter like how you move it around. The quantity is the same. Here's a quantity of 3. Here's a quantity of 3. That 3 and 3 is always going to be 6.
And this 3 is 9, and this 3 is 12.
Awesome. In fact, that's perfect. That's right where we want to go as far as multiplication. But we talked about... yeah. I was worried about that. That's probably not the best setup. Try that. No, but then we can't see. Let's start this over. I don't know.
Okay. Sorry for that blast.
Well, I mean, the problem is we were bouncing the table too much, and this isn't set up very well. Yeah, make people sick. Doing that. Okay. I don't know. Not very high quality, but we're doing this. Okay. Boy. Where were we?
Oh, we're on quantification, bro.
Right. And so we said that because the consistency of math. Let me.
Pause. Well, sorry for that interruption.
Are we going? We're going. Okay. Did you start over? No. All right.
No.
So we talked about addition. You have your set, right? And maybe we'll call it our control volume like we did before. And whenever you have something, here's more control volume. Whenever you have something going in, you add to that control volume. You have another set, you add to that control volume. I know, there's a reason I did it like that. But then if you have some going out, you take it from it. That was addition and subtraction. Subtraction was just vector addition. In other words, if it's going out, it's minus. If it's coming in, it's plus. Now, you had this all set up. And there's a reason why I wanted you to pick out 12 of the same color. Because look at this, you have this in groups. What happens if you have the same amount coming as this each time? There's one group of 4, one time. Here's another group of 4, 2 times. Here's a third group of 4, 3 times. Right? And so, what did we find out? What was this?
12.
So we said that. What we did, 4, actually, let's say they were groups of 4, right? So we had 4, 3 times, or times 3, and that was 12. Now, when we originally had this set up, we had it set up kind of differently. Can you set it up another way? With the same 12 things? What if we had different size groups?
Oh.
So,
2.
groups of 2? Okay, so you have 1 group of 2, 2 groups of 2, 3 groups of 2.
4 groups of 2, 5 groups of 2, 6 groups of 2.
Oh, so you had 2, 6 times. That was 12. Okay, how else can you set this up? Well, I noticed here, look at this. You did something interesting. You had 3 groups of 2 and 3 groups of 2. So you even had here, you had 2, 3 times, but you had those groupings times 2.
Oh.
And that was 12. Look at that. You did 2 times 3 times 2. Are there other ways you can set this up? What are other ways you can set this up? Oh, now you have groups of 3. So now you have 3 times 4. So you have 4 groups of 3 equals 12. Now you notice 4 times 3 is 12 and 3 times 4 is 12. And so this is called the commutative property of equality. Mathematicians, they're all about finding fancy ways to prove it's this way, but we just showed it here kind of simply that 4 times 3 and 3 times 4 is the same thing. We can do this graphically. Look at this. If we do 1, 2, 3,
look at this.
4, 1, 2, 3, 4, 1, 2, 3, 4, that's 3 groups of 4, that's 12 dots. Or if we went 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, that's 4 groups of 3, that's 12 dots. And it's like we take that same thing and we rotate it. Now you notice over here you had 6 groups of 2. So 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, and that was 12. If you went this the other way, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. It's like you're rotating a square, huh? And you get 12 either way. Now, a lot of times, and you learn this, you think about and look at into the next thing I want to do is continuous versus discrete values. If you look at this, we go a distance. We often talk about going distances. What if we then go that distance in an orthogonal direction? I want to go like that. When we talk about how much area did we cover, how do you find area? How do you find area?
1, 2, 3, 4,
Well,
5, 6.
I don't want to know what the actual area is, but we say area is your length times your width. Notice, look at this, we made boxes. And the box was how far over times how far down. That's your area of the box. How far over times how far down.
That's 6 times 6.
Yeah, if you had a square with 6 over and 6 down, you get 6 times 6. Now we did the associative one here. Can you change this one here?
Yeah.
What if we did 2 times 2 3 times? So we go 2 times 2. Oh, there's a group of 2 times 2. 2 times 2. There's a group of 2 times 2. 2 times 2. There's a group of 2. And look, how many do we have? So if we go 2 times 2 times 3, it's still 12. So the fact that we went from 2 times 3 times 2 to 2 times 2 times 3, and we got 12 the same way, that's called the associative property of equality. Doesn't matter how you associate these together or with each other, they still get the same amount.
Or parentheses addition.
Well, this is all for multiplication. So these are 2 properties of equality that you find for addition and multiplication. And there's a third property that's kind of interesting called the distributive property of equality, but that requires both multiplication and addition together. And we won't get into that one yet. But it's kind of a basic introduction to algebra.
Okay.
We showed how to go over some simple multiplication on the abacus. We showed these ways that multiplication works. How do we think about multiplication? Can you remember we talked about the whole thing of math is to help us understand the world around us. What's a real life use of multiplication?
If there's 3 cows and there's 3 cows, there's 6 cows.
No, that's addition though. We have 3 here and 3 there. What about, we often talk about rates when we talk about multiplication. So let's talk, what is a rate? That's when you do get something for something each time you do it. Okay, so one rate might be like miles per hour. If I'm going 60 miles per hour and I travel for 2 hours, then I go 60 miles each hour times 2 hours is 120 miles, right?
Ooh.
But an easier one to think about would be money. What if I gave you, I don't, but what if I gave you $2 each time you did a chore? And you did 4 chores. You'd get $2 the first time you did the chore, $2 the second time you did the chore, $2 the third time you did the chore, and $2 the fourth time you did the chore, which is 2 times 4. Because of $2.
$8.
$8 in all.
Dad.
Now, when we talk about rates, sometimes we talk about like what is your hourly rate? How much do you get paid? You go to work and they often pay you in a rate. Maybe it's $20 an hour. It's a good job, huh?
Okay.
And let's say you work 8 hours a day. If you're getting $20 an hour and 8 hours a day, how much money do you make a day?
Okay.
Anything on that?
I
What's
don't know.
20 times 8? Because you do $20 an hour times 8 hours.
28.
No, that's addition. You're getting distracted. What's 20 times 8? So let's do it. Say each of these is $10. You get $20 the first hour. $20 the second hour. $20 the third hour. $20 the fourth hour. $20 the fifth hour. $20 the sixth hour. Extra $20 the seventh hour. $20 the eighth hour. So what are you gonna get? 20.
20, 40, 60, 80, 100, 120,
Yeah, 120.
140, 160.
160. So we said, let's do this. So we had $20 an hour times 8 hours is how much?
160.
160. Now you've seen this. You've done this type of multiplication before, haven't you?
Yeah.
Look at 8 times 0 is 0. 8 times 2 is 16. Yeah. We'll get more into that when we get back to the abacus next time. But that's just kind of a quick introduction to how to think about multiplication.
And then...